Hi class, this is our 8th online lesson and our 7th in the series of dynamics. See, when I'm saying dynamics, I mean chapter 4, 5 and 6 in your textbook. So this series of dynamics is 3 chapters. So by the time we'll finish dynamics, we'll be finishing chapter 4, 5 and 6. These 3 chapters from your textbook. Okay, now in the earlier video, the earlier lesson we studied about the frictional force F max equals to mu r. We'll continue with that. Now we'll connect it particles with pulleys and all. Let us take example. This is a question from your textbook. A box A of mass 2 kg is held at rest on a rough horizontal plane which is inclined. See that it is inclined. We just studied in the previous lesson. 30° to the horizontal. The coefficient of friction is given. The mu is 1 by root 3. Box A is connected to box B. So there are two particles connected. The masses are given and they're connected by string and passing over a smooth pulley. We have to find the acceleration. First, let me draw this scenario. Okay, so now you see there is a particle of mass 2 kg which is connected. So this is that string and it is connected to another particle of mass 3 kg. This is the pulley. So this is the setup. The other lines that you see here, these lines and the lines here are the forces that I have drawn. You know, the forces will always be the hidden forces which you have to do on your own. Like this is a mass, so it will have a weight acting vertically down. Reaction force will always be perpendicular to the surface. Friction will always be parallel to the surface, and the tension will always point towards each other. So this is the setup at B. So you have two forces at B and this is at A. Okay, let us start. You can start from B, you can start from A, it's up to you. Okay, I've taken A first. At A, it's very important to mention this in exam. So at A, so you're talking about this particle now, resolving this as positive. So we're talking about this force now, this vertical force. And now we're taking this as positive. There are only two forces. One is up, and we studied in the previous lesson how to resolve the component. Because this is neither horizontal nor vertical, you need to go parallel to R and parallel to horizontal to resolve. This is opposite, that's why sine theta. This is adjacent, that's why cos theta. So while resolving this component, I can say upward force will balance the downward force. So R should be equal to 2g cos 30. And everything is a constant. You can find g is gravity, cos 30, everything is a number. Next. Now at B, so we are here now. See now at B, the object, like see on this plane the object is in motion, accelerating with acceleration A, and remember, because they are connected, both the particle will move with the same acceleration. So this particle A is moving up with acceleration A, at the same time particle B will move down with acceleration A. So now dynamics will come and our magical formula, resultant force equals to ma again will come. So F equals to, you use, because it is in motion, F equals to ma. We're taking downward as positive because it is going down. So 3g will be positive, t will be negative. This is your resultant force, mass, acceleration, and you got an equation of t in terms of a. So we have an equation now with two unknowns. So we need one more equation to solve them simultaneously. We can go back to a and resolve the horizontal component now. Let's take the next slide. Okay, this is just the same thing what we did, and this is our new slide now. Again at A, if I resolve this now, horizontally it is in motion, so again Newton's law, F equals to ma, resultant force is mass into acceleration. Now horizontally there is a force tension here, there is a force 2g sine 30 which is in opposite direction, and F is a force in opposite direction, so this 2 will be negative. Okay, t is positive, these two are negative, mass into acceleration. Now what we are doing is, because there are too many unknowns now, F is another unknown. Okay, so what we can do here is, we know the formula for F is mu r. So mu r, mu is given, r we already have from here. See, everything is a constant, g is known, cos 30, everything is known. So it's better to get rid of this variable and bring something which you already know. So F equals to mu r, we substitute 1 by root 3 r, and then we substitute r here, and hence, and also we know t is 3g minus 3a. So in place of t, I am writing 3g minus ta. The whole intention is to make this equation in only one variable, which is a. So everything, this entire equation just have a single variable a. This is just simultaneous equation, and this is not the only way of doing it. There are many ways of doing simultaneous equation. You can use any way. There are three equations, solve them simultaneously. and simple mathematics will give you the answer 1.96. That's it. Let's take the new question. Okay, this is now we are starting chapter 6, momentum and impulse. Let's start. Okay, first of all, let us understand what is impulse. Basically, impulse is force multiplied by time. The impulse of a force is given by impulse I equals to F into time, force into time. See, we know the formula for acceleration. It is V minus U over T, and we know F equals to ma. This A, if I just substitute here, if I open the bracket, rearrange, take cross multiplication, F into T is mv minus mu, and Ft we know is impulse I. So we got another rule for impulse. Impulse is nothing but the mass into velocity, final velocity, mass into initial velocity. We know mass into velocity is momentum. So basically impulse can also be said as the final momentum minus initial momentum, or impulse is the change in momentum. Impulse is force into time, or impulse is change in momentum. Let's take some example. Okay, now this is exercise 6a, question 1. A ball of mass 0.5 kg is at rest. So ball is at rest when it is struck by a bat and receives an impulse of 15 Newton second. Find the speed immediately after it struck. It is always advisable to draw this scenario. See what I am doing here. So let us say this is any ball. This is the bat. We know the mass of the ball is 0.5 kg. And impulse is given from bat to ball. That's why the direction of impulse is very important. Impulse, see, receives when it is struck by a bat and receives. So ball receives an impulse. That's why the direction is from bat to ball. So this direction of impulse 15, and bat is going in this direction because it will hit the ball. Let us make an equation now. You see, impulse is change in momentum. So it's mv minus the final momentum minus initial momentum. Remember, when we talk about final momentum minus initial momentum, it is the same object. You can say final momentum of ball minus initial momentum of ball. It should be ball and ball. Don't take two different objects, please. You can take final momentum of bat minus initial momentum of bat. So it has to be from the same object. So mv minus mu, you take m common, v minus u. V is what we are finding. U is the velocity of ball, and ball is at rest. That's why u is 0. Simple maths, you'll get the answer. So velocity is 30 meters per second. Clear? And the direction of impulse and the direction of velocity is same. That's why we are taking this velocity as positive, and you have to be very careful with that. Sometimes the direction will be opposite, so you should take negative v and all. We'll take in the next example. Okay, you pause your video now, please. Try to draw this with the help of a diagram and solve on your own, and then we'll continue. Okay, let's take this question. So this is what is happening. A ball of mass 0.5 kg. There is a ball of mass 0.5 kg. It is dropped. Remember, drop means the initial velocity should be 0, and because it is in dropping the gravity, acceleration due to gravity, we know 9.8. So now we know the total height while dropping was 2.5 meter. After hitting the ground, the ball it bounces to a height of 1.8. So initially 2.5 bounces back to 1.8, which is very obvious, and there will be some loss in energy when it will bounce. It will not go to the same height, but obviously. Okay, so now see, when we are working with magnitude of impulse, impulse is the final momentum minus initial momentum, and momentum is mass into velocity. So we are interested in velocity. So what they have given us, they gave us u, they gave us s, xl, to make a kinematic situation here. But our whole idea is to find velocity now. So let us do it. So now taking downwards now, and when this was going down, we know it is dropped. So we know initial velocity is 0. We know 9.8. We know the distance is 2.5. With the help of this, using the kinematics formula, we got v as 7. So this is when it hits the ground, the velocity was 7. And in the upward direction, again, if I take, we don't know what is this velocity here. We are finding this. Okay. Initially, we don't know. Acceleration is reversed, so it is minus 9.8. It will reach the maximum height, so maximum height velocity will be 0, and displacement 1.8. Again, using kinematics, we can find u is 5.94. So before impact, the velocity was 7. After impact, the velocity is 5.94. So now we know the velocities. Now we can go ahead with impulse. Okay. Now, because this is the direction of impulse, find the magnitude of impulse received by ball from ground. So from ground to ball, so the direction will be in this, this is the direction of impulse. You have to be very careful with that. So if I take this as positive, impulse is mv minus mu, m common, v minus u. V is the velocity after impact, this is the initial before impact. Velocity after impact, see after impact it will be going up, that's why this will be positive, minus from the formula. Initially when it was going down, the direction was opposite to the impulse, that's why -7. This is very important to be careful with this, okay, because while going down the direction was opposite to the direction of impulse, that's why it will be negative. You solve simple mathematics, you will get the impulse. Next,